Okay guys, on this notes, we are learning how to factor polynomials, more specifically quadratics. The first type of polynomials, we're going to take a look at some linear ones, some quadratics, cubic, and so forth. So the most basic polynomial to factor is factoring out the greatest common factor. So in our first example, the greatest common factor of these two terms is 6. So we're going to bring the greatest common factor to the outside, and then once we factor each of the terms by 6, we have 3x minus 2. So the two factors are 6 and 3x minus 2. We could check our work by redistributing the 6 to get back what we started with. So remember, when we are factoring and rewriting expressions, each new expression still is equivalent to the previous one. The next one we have here, we can factor out a 3x. Each term has a 3 and an x to factor out. So 3x is going to be the greatest common factor. When we divide 24x squared by 3x, we have 8x minus 7. And again, I could redistribute the 3x and multiply by each term to get back what we started with. Number 3, we have a trinomial. And remember that anytime your leading coefficient is negative, we must factor out the negative. So we can factor out a negative 4x. When I factor or divide negative 4x by each of the terms, I'm left with 3x squared plus 2x minus 1. If I start with a trinomial and I'm factoring out a GCF, I will still end with a trinomial. So these are my two factors, negative 4x and 3x squared plus 2x minus 1. Remember, when you're dividing exponents, so for example, x to the fourth divided by x to the second, you subtract the exponents because I have x times x times x times x divided by x times x, so that leaves me with x squared. Let's take a look at our fourth example. Our leading coefficient is negative, so we're going to factor out a negative 3xy. When I divide negative 3xy from each of the terms, I'm left with positive 1x minus 2. Again, we could redistribute to check to make sure we are correct. And the last one, for the greatest common factor, we have a leading coefficient of negative, so we have a negative 1 x squared y. When we factor out negative x squared y from each term, we're left with positive 7x y minus 1. And that's how you factor when you can only factor out a GCF. The next step we're going to take a look at is when we have a quadratic trinomial, when our a value is 1. So a reminder that standard form for quadratic expressions is ax squared plus bx plus c. In this column of problems, we're going to factor by grouping, and our a value is going to be a 1. So these are easier than when a is not 1. So what we're trying to do is we're trying to find the two binomials. We're going to do two linear binomials that gave us this quadratic trinomial. So to factor, we're going to factor the x squared into x and x. And then we're going to factor the positive 12 into two factors that still add up to 7. So if you like to use the graphic organizer where we have a times c on the top, so 1 times 12. And then the sum, the b value, is in the bottom. So we're thinking of what two factors of 12 add up to 7. So 3 times 4 is 12, and 3 plus 4 is 7. So our two linear binomials is going to be x plus 3 times x plus 4. These are the two factors. Our next one, our a is 1, so we can just immediately set up for the linear binomials. We're factoring x squared into x and x. we're going to factor 12. So A times C is the top product, and B is our sum. So we're thinking of two factors of 12, so 2 and 6. 2 times 6 is 12, and 2 plus 6 is not 14, so that is not. Oh, I think this one had the error on it. Yeah, we were supposed to change this to a 13. Okay, so it's supposed to be x squared plus 13x plus 12. So now this works, 12 and 1. So 12 times 1 is 12, and 12 plus 1 is 13. Those are your two factors. Our next one, this time we're going to have to consider a negative. So we're going to factor x squared. Our A times C is 12, and our B value is negative 8. So we're thinking of two factors that give us a positive product. So negative 6 and negative 2. That does give me positive 12 and a negative 8 if we were to add those. So x minus 6 and x minus 2. We have negative 18 as a product, negative 3 as a sum. So we're thinking of what two factors of negative 18 give us a negative 3. So negative 6 times 3, so we have x minus 6 and x plus 3. The last one here, factoring x squared into x and x, we have negative 18. So that looks like negative 9 and a positive 2. Nope. Let's make the 2 the negative because we have a positive 7. So plus 9 minus 2. So that is what it looks like when you have a quadratic trinomial and your A is 1. Now let's look at our third column. So our third column is putting the first two ideas together. So we're going to have a GCF, and once we factor out the GCF, our A will then be a 1, and then we can quickly factor the two binomials. So we can see here that we can factor a 2 out of each term. Bring down the GCF, set up for your two linear binomials, factor your x squared, and then we're going to factor A, which is 1, times 24, and our B is 11. So 8 times 3 gives us 24, and 8 plus 3 is 11. So, and again, it doesn't matter the order of where you put your factors. So 2 times x plus 8 times x plus 3 is your final factored answer. Here we have another leading coefficient of negative, so we need to factor out the negative 1 first. That gives us x squared plus 7x plus 12. Set up for your linear binomials. We have 1 times 12 and then 7. So it looks like 4 and 3 or 3 and 4. So factor x squared, factor 12 into plus 4 plus 3. Here we have a negative 2 as a GCF. Set up for your linear binomials. Please do not forget to bring down the GCF. So we have negative 21 is our product, negative 4 is our sum. So it looks like we have a negative 7 times 3 are the two factors. Again, don't forget your GCF out front. Our last one here, we have a GCF of 3. Set up for your linear binomials. We have 1 times 20 and a sum of 9. So 4 times 5 is 20 and 4 plus 5 is 9. Okay, so that is when your A is 1 after you have factored out the GCF.